start recording these. Good. Are you able to see my screen? Good. So I think we are set. We can just start. And I think I'll start by creating a new cell here. I think you can just create a new file. Let me just upload this. Open notebook. Let me just create a new one. Yes, I'll call this file EDA. That is EDA underscore. Let me just call it EDA process. Good, I think that is it. So let me just add these steps. So you're going to have first, this is not step one. And in step one, we are going to have data understanding. I think you can just make this bold. Let's just call it data understanding. Then step two, we are going to have data. This is step two. We're going to have data understanding. Oops. Understanding. Then lastly, we are going to have, let me have this code and let me just have the step three. In the step three, we can have feature understanding. Yeah, so in each step, you are going to have a number of functions that we are going to check. And I would like us to start with data uploading, because you cannot start to understand data that you have not loaded. So you can start by uploading the data set. I think we started by I think you now guys know how to load data set. And for you to load the data set, we have another step that we call, of course, we must we must import the libraries that we are going to use. So I think that is the first step. So let's, Rodovan, Musembi, it's a question. Is it a question?
Yeah, I think you wrote step 1 data understanding and step 2 data understanding. Is it the same?
No, 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 no. It should be data preparation, not understanding. I think it should be data preparation. Thank you for that, Rodo. It should be preparation. Preparation. So we start by importing. I don't know what is the problem with my. Oops. What is not happening here? I think there is a key. My key is not functioning here. So let me just try to copy the M. My M key is not functioning. I don't know what is the problem. I think you can just let me just try to copy this. I think I can as well as copy M so that I can use it anytime I want to do the importation. So we start by importing pandas. I think this is what I should write here. So we start by importing uh, importing libraries. Should be libraries. So that is import pandas. I think by now you know how to import pandas as PD. We import numpy as NP. Then for the case of visualization, we can import, let's have matplotlib and also seedbone as ls. You can have, I think those are enough for now. So let's run this. Just to make sure that everything is functioning well. Good. So let's start by importing data. Let's have this. Something we call loading data. Loading the data sets. Okay, how do we load the data set? I think you guys, you can remind me how we do it. Before even we think of loading it, let's upload it in our working directory. So I just have to upload. Let me upload this very fast. It's a large file. In fact, this one is it's a large file. That is so it's taking sometimes to even load. Let's see, give it a minute. It's loading. I think it has finished. Good. So we say for us to load this dataset, we use the import that the PD, and because in fact this one is a CSV file, so we have just to use we can call it df is equals to, that is the pd.read_csv, and then we have the path. So I showed you how to copy the path for this. Let's copy the path. We can copy the path, and this should be in opening and quotation marks. So let's try this. And now you notice that we have a problem here. Let's see what the problem is. I don't know if you guys are able to see that we have a problem with the Unicode. It's the Unicode decode error. By default, we use the UTF-8, but with this data set, we are going to use a different decode a decoding options that we have. We are going to use, let me counter check that we had, I think with this one we are using the encoding ISO 8859. This one is more specific, but in most cases you use the UTF. Let me just copy this. And in case maybe you find some errors, the decoding error, you can as well as try different. You can also try different encoding options that we have. By default, you always use this one. Let me show you. Why is this? Oops. Did we lose that? Just a minute. You can see that we have a problem with the Unicode decode error. This is simply because for us to read this data set, let me show you that. What is this? I should minimize this. For us to read this data set, we must include an encoding option here, because it isn't using the default UT, is it the UTF-8, but with this one we are using a different encoding option, that we a different encoding option, so which is the ISO -8859 -1. But you don't have to cram all these encoding options that we have. You can always Google these and try the one that will work for you. But with this case, because I think I was doing some analysis with this data set, so I already know that the encoding used for this is this one, the ISO-8859-8. So if I try now to read this data set, I should be able to read it without an issue. So let's see that. Let's see this. And I think you can see that we have managed to load this. I think you can just pick the first five columns. You can see that it is taking much time to even read the first five rows of data, because it's a large data set that we are using here. So this one is a data. I think someone is saying iPad on something. Let me see what that is. Oh, yes, I can see. Harriet. He's asking why we are using encoding. Harriet, we're using encoding because with this data set here, when trying to read these files, of course, it's kind of we are trying to decode those files, and we have different decoding options that we have when trying to read these files. So for us now to be able to read this CSV file, we must use in fact this one is a large it's a large data set, and it is the way it was created. I think that the way it was created, it means that we have to do some we have to use I think it was decoded with a different decoding options that we have. So to encode when reading this data set, then it means that we must use the decoding, and we must use an encoding option that we have. I just tried to read. I just tried to use the by default we use the UTF -8, but with this dataset I tried the UTF -8, but it didn't work for me. So I had to look for the other options that we have, and the option that worked for me was this one, ISO. That is I think even we can just try to check this. Oops, sorry, to check the encoding this one so that we can have some more information on it. Oops. Let's check this. Let's check this encoding option that we have. You can see that we have the UTF. Let's check this one. I think you can see, let's just, I just want to get some more information on this. That is the encoding character length. Let me check this one. There is so much information about these encoding and decoding. You can see like this one, it consists of, that is 191 characters. That is from the Latin script. But we have the normal the UTF-8. I think the UTF has, is it 255? I think you can just try to to Google, just try to do research on these encoding and decoding options that we have. I think the information is readily available in the internet. Um, but it's more on encoding and decoding. You can just try to do research on that. But with this one, you must use the encoding because of this dataset nature. So I think this is this is the first step that we use. This is the first step that we must carry out for us to continue with the EDA process, and that is the data loading. So after loading this data set, then we have to, the first step now in the EDA process is just to try and maybe gain more information on this data set, and that is why we are starting with this type of data understanding, like understanding how many like columns we have in this data, how the length the length of these data. That is now by using the data shape of checking the shape of this data set. This data set, that is checking the rows and columns that you have in this data set. Checking the names of the columns that we have. You know, just general understanding of the data set that you are about to do analysis. Um, also in this step you can carry out the statistical summary using the describe function. Also you can use the tail and the head functions just to to get an understanding of the data set that you are going to deal with during the analysis. So like with this data set, it's a data set that is used. In fact, this is the data set that is used to predict, that can be used to predict, that can be used to predict. Uh, I know most of us are familiar with football, and that is why I checked these. I'm using this data set simply because it's a large data set. In fact, it has information about players, and we have players. That is the name of the players. We have the nicknames. That is what we are calling the short name. We also have the player picture. Also in this data set, I think you can see the links that we have, and also we have the that is the players IDs, and also we have the potential of a player. Just leave alone these the overall. We are going to see what the overall means when it comes to analyzing this data set. So again, we have the data on how much they earn. That is that is in euros. We have the I think for us who are familiar with football, each player is marked is given a value, right? Like I don't know the current the current price for players like Messi, the current value for players like Ronaldo. You know, they are they have their prices. Also, they have the money that they earn either weekly or on a monthly basis. But in this case, it's a weekly basis. Then we have their age. We can see like someone like Robert Lewandowski. I think when this data set was corrected, he was 32. We have the option we have the positions that they play in in the field. Also, we have how best we have the information on how best they can play in different places in that field also. So we have so much information about these players. In fact, their country and their country flag. We have their national logo. We have so much information uh, about these data set. In fact, what I was just doing the analysis just the other day with now machine learning. It was it was something to do with the player performance rating prediction using a machine learning model. So using these data set. But today our focus is not on predicting these, not predicting the players' performance ratings. Our focus today is something to do with we just want to have a general understanding of these data set using the EDA process. So, and I think having said that, we can just proceed to the next part of our EDA process, whereby we are going to we can just have a check. Let's have a check on. I think you can just start with the head and I think you can let's start with the head and tail functions. So with this head, as I had said earlier, with the head function, we are calling our data set df dot head. We said by default, this head function will always give us the first five rows of data. That is what we say. And in fact, if you are just to run that cell, you notice that you are getting the first five. That is the first five rows of data. With this, you're able to see in fact, you're able to see the column headers for your data. It's just some of the data under those columns. Like you can see, we're starting with the one that is at index 0. We have the player URL. We have I think you can let's check if you're able to see the picture for these. Let me just try and copy these and see if you're able to see the image for Messi. Oops. Don't think. Let me see this. Um, but I think this one is supposed to be a URL to find the image for Messi, but I don't know why it is misbehaving. But this is just a plain URL, just to show you the image. We have the name. These are the kind of information you get by just having the df.head. You can also, if maybe you want to get like the first 10 rows of data, you can just pass 10 in this function. You can also pass 20 um, just to have a look at the first 20 rows of data that you have in that data set. We said that different machines have their limits, and we saw that most of the machines will have you can only display 60 rows of data at a go. So let's see the first 60. And we said now if just maybe input a value that is greater than 60. You notice that you are going to have let's see what you're going to get. You notice that now you are getting the first five rows of data, and the last five rows of data. So meaning that, like in this laptop, the maximum, all the limit that you can display at a go is 60 rows of data. So it's always good to understand these things. These are some of the things that you can be asked maybe during an interview, how these functions works. So the next function is a function that is called tail. That is the df.tail. And with the df.tail now, you are going to get the last five. In fact, if I was to run these, I should get that is the last five. That is the last five rows of data in my data set. You can see my data set has how many? how many rows? That is 19,238. So these are some of the information that you get with the tail function. So maybe something else that we can check from our data with our in this step is something to do with the data types that you are dealing with. So it's always also good to know the data types that you are dealing with. And I think I can just have that one is checking the data types of our columns. Oops. I think I need to copy the M again. Let me just have that. That is column. And this one is easy. We just have a function. In fact, this one is not a function, but you can just have a df dot. That is, we call it d type. Df, no d. It's called d type. I think it should be like that. Let me check this. Yeah, we have df dot d types, and if I run these, I should be able to see the data types of each column. So let's wait for it. Hello, just a minute, please. Okay, someone to confirm that you can hear me. I think we have issues with the stable internet, but I think that one is going to be sorted. Hopefully soon. So I was saying that you can also check the data types of the columns that you have. Uh, and we do that by using the df dot d types. Let me just run this again. I should run this once more. Uh, Let me just rerun these. We can also rerun these and now have the data type with the df dot d types. With this one, you are just going to get the data types of the data that you are dealing with. That is in each column, and you can see we have a mix of data.
I think we are not seeing your screen. Is it on my side only?
Yes, I think I didn't resume that. Thank you. What about now? Good. So let me just focus on this screen. Yeah. So I was saying that these df.d types will give you the data types of each column, and as you can see that we have a number of data types in each column. Like you can see, we have data types like object. We have the int64, that is the integer 64. I think most of them are objects. So again, this one now helps you to decide which data sets, which columns you're going to change the data type. For instance, if maybe you had a column with date. I don't think we have a column with date here. But in cases where you have, let's say, a column with a date, and maybe it's of data type object, you can change that one to a data type, to date time data type. So I think that is it. That one will help you to this one will just help you to decide which data sets are you which columns you are supposed to change their data types. So I think that's all with the data types. And I think the last thing on this data set understanding, I think the last thing that you can maybe check here is now the statistical summary for numerical columns. And with that, we use using the describe. This is function. This is to check to check statistical summary. That is the statistical summary of, that is the statistical summary of numerical columns. This is described. And you guys, you know how we use it. We just have to invoke that is our df, that is dot describe. It's a function, so we can just try and run this. And again, now we have we can see how our data is distributed across all the columns. With this, again, we are able to see uh, the count for each column. We're able to see the mean of the that is the numerical columns. We're able to see the standard deviation of each column. We're also able to see the mean and the max value that is in each column. Again, we're also able to see the quartiles. That is the first quartile. The we have the lower and upper quartile, and also getting the yes, I think that's all. That is the mean and max value, getting the quartiles, standard deviation mean, and the count for the numerical columns that we have. I think you can see. Let me just try to check something here. We can see the highest player with the potential has a potential of 95. This one must be maybe Messi, or I don't know. It could be Messi or maybe Ronaldo. We have the player earning the maximum wage. He's earning around that is 50,000. This is 350,000 euros. This one must be weekly wages. So then we can see the player with the oldest player. The oldest player has an age of 54. So with this kind of a statistical summary, you're able to derive or have the statistical summary of your data. So that is also that is a function that you can always use during the EDA process, just to understand the distribution of the data set that you are dealing with. So there are so many functions that you can use in this step, but I think you can just stop at that in this step. So, because again, there are so many functions like the summary. We have the summary function. We have the info function. I think we have used the info functions several times, and so you can maybe let me just use the info function so that you can get the general that is the general information about this data set. And we can see that we have around that is 19,239 entries of data, and this ranges from 0 to 19,238. We can see the number of columns that we have, and we have 110 we have 110 columns in this data set. We can also see the data types that we have. We have the float, the 18, we have the int, the integers data that we have, that is 44, and then the object type we have 48. When you sum this, is supposed to give you about, it's supposed to give you is it 110? What is 18 plus 44 plus 48? I think this should give you a figure of maybe 110. And then we have the memory usage for this data set. You can see it's quite a large data set that is occupying, that is 16.1. That is MBs of local storage. So those are the kind of information that you can get in these during the data understanding process. I don't know if there is any question on this step before we proceed to the next step. Do you have any question? Any question from this? Any question before we proceed to data preparation? Okay, thumbs up if you are together. Yeah, I can see most of us we are okay. In fact, this is the simplest step in the EDA process. So let's get to the next step of the EDA process, which is data preparation. With data preparation here, this is where you are going to carry most of things here, because the data preparation just means that we are trying to clean our data. And cleaning data can mean many things. That is including maybe having subset of these data set, because you understand that this is a large data set, and based on what you are doing analysis, you can just choose to have a subset of these. Like maybe when maybe you are checking, like when I was doing analysis on that was analysis on the prayer performance ratings. There is so many columns that I didn't use, and that is now where the subsetting comes in. That you can have columns that you are going to use for your analysis. That means you are going to drop a number of columns. You're going to drop a number of columns based on the analysis that you are doing. So in this case, I would just like to check about the dropping of irrelevant columns and rows. We identify duplicates in our data set, and then we see how we can do renaming of columns. Yes, I think you can just check how you can rename columns, and then I can show you how also to do what to create other columns. That is based on the columns that we have. But mostly this is determined by the kind of analysis you are trying to do. Basically, now answering basically answer just that means that the business question that you are trying to answer. That one will determine if you are going to create other columns, or the ones that are provided for you are enough. So I would like maybe to start by checking the missing values. Maybe you can check the missing value. Let's start with the checking of missing values. Missing. Let's call it missing. Missing value check. Missing value columns check. So we can always check if they are missing values in our data set, and we use the is null function. The is null function, this is how we implement it. We can have df.isNull. That is the is null. So when we run these, we are going to see that is the false. We are going to see false and truths in our data set. This means that we have, where we have a false, it means that we don't have a missing value, and where we have a true, you notice that there is a missing value. But you notice that this one is when maybe you have now a data set like this one, going through these columns, checking that is false and true. That one can be a bit overwhelming. So what we normally do, we introduce another function that is called dot sum. That is dot sum, so that we can get missing values in each column. So let's see what we have. Let's run this. Oops. What has just happened? Yeah. So we have the df.isNull dot sum. So this one is going just to give us the sum of all null values in each column, and you can see like the club logos here. I think you can add something here. Let me see if dot head will function here. So that you can see the first 50 columns. Good. So if we go through these columns, you can see for the FIFA ID here, we don't have any. We don't have a missing value in that column. And also for the player URL, we have the short name. Also, we can see we have zero null values. But when you get to the value, that is value underscore euro. This is the value. This is the value for the player. We can see that we have about 74 places where we don't have the value for the player. We can also see that in the wages, in the wage column, we have again 64 missing values. When we go down, we can see also the club team ID. We have like 61 missing. When we get to the club underscore loaned from, we have so many missing values. That is about 18, that is 18,137. So this one just means that a player has been loaned to a certain club. But you notice that many players are maybe bought from various clubs. So meaning that we can have these large numbers. of club loan from, simply because most players are bought, not loaned. We have the national underscore team underscore ID, where we have again that is 18 for 80 values missing. So with just that one function, you're able to go through like the first 50 columns of your data set, just checking if you have null values in each column. So with this function, it will help you decide if you have a task, if you have a task on, if you have a task for replacing the null values or the missing values with other values. Now that one depending on the analysis that you are going to maybe the analysis that you intend to do. Like you can see also we have like in the also the shooting in the shooting again we have like 21 32 values missing. That is so the shooting, that is the passing, dribbling. We can see it's kind of there is a problem here, uh, whereby we have the pace, shooting, passing, dribbling, defending, having 2,132 missing values. So with this now you can you're able to decide if you're going to feel. In fact, this one will just help you to understand the columns that have many missing values, and then now based on that you decide if you are going to fill those columns. So okay, thumbs up if you are together up to that point. Yeah, I can see the Tuze Bidhaa we are together. I can see Mumbi, Joseph Kilo, Grace Kemani. What about the rest? Yeah, we have Shalette, Megan. Yeah. So I think by now I just gave you that I just gave you that data set. But by now you are able to by now you have an understanding of what you are dealing with just those functions that we have used. You can easily give just a summary on the data set uh, the data set that we have that we are working with, the data set that we are working with here. So you can see how Python is powerful when it comes to the data analysis. In fact, if you are to go, let's say maybe you are to check these data set, just using your maybe you going through row by row. I think these are some of the things that you can never realize with such large data set. But now with Python, you're able to use these functions to understand the data set that you are dealing with. Um, Something else that I would maybe uh, that I would like us to check in these that we are going to check is something that is called. We can see how you can do renaming of columns. But again, with this data set, we don't have much problem with the naming, because we can see the naming is uniform, because we can see that if we have two names in a column, they are separated by an underscore. I think the naming here is the naming here of the column is it's quite uniform. That is the attacking underscore volleys. We have attacking underscore shot. we can see that the naming of our columns are good, but this is not always the case. You can have cases where you have columns that are not named like uniformly, such that maybe you have cases where we are using the snake case technique. Other cases are using the camel case, and you need to have a uniform. When doing analysis, personally, I like to have uniform naming, that is in all columns. I think that is something also you can adapt anytime you have anytime your columns are not named uniformly. Maybe you should try and make sure that all the columns are named uniformly. Either you use the techniques that we studied, that is either camel case, this you can also use the snake case or the Pascal case. But I'll just show you how you can do the renaming of the column, um, so that anytime that you want to do the renaming, you will not have difficulties in doing that. So let's have something we call uh, renaming. I think this is the last thing that you are going to check. Renaming of columns. So it's quite easy how we use the it's quite easy how we do the renaming. Because let's say maybe we want to rename something, maybe we can start with the sole FIFA ID. Let's say maybe you want to have, instead of having sole FIFA underscore ID, let's say maybe you want to have FIFA underscore ID instead of having the sole FIFA underscore ID. There is a function that is called rename, and we are going to use the df dot use, it's called the u yeah, that is this is the name. If you can have the name, it's a rename function. And with this function, we are going just to specify that we want to rename the columns. This is the columns. And then after that, we are going to have a dictionary here. This is now where you pass the names of columns that you want to change. In this case, we just want to change this one. Let me just copy this. The sole FIFA underscore ID. Let's copy that too. Here. So this is the syntax. That is the df dot rename, and then you pass in the columns, and then you indicate the name that you want to change. In this case, you want to the column name that you want to change. You want to call this FIFA ID. So let me just copy that to. Let me just copy that. So we have FIFA underscore ID. So with this now you're able to rename uh, to rename this FIFA ID column. So maybe you can also try to let me just try to run now df dot head, and I want to check the first 5 columns after renaming the FIFA ID column. Oops, I think this didn't take effect. Let me just try to let me call this new df. We can then let me just try to have that. So you can see now that we have changed the FIFA underscore ID to FIFA ID to FIFA underscore ID. Sorry, and maybe if you want to change a number of or multiple, you want to change multiple columns, you just have like to add a comma and say like maybe we want to change the player URL, the player underscore URL to. So you just have to copy that into opening and closing speech marks, and then we just pass in the name that you want to name this column. Maybe you can call it player underscore link. So if I run this again, you notice that there we have player underscore link instead of player underscore URL. So I don't know if there is any question up to that point. Do you have any question? Can we extend maybe for 10 minutes so that you can see how I think can we extend? Let me see by show of hands. Can we extend for 10 minutes? Yeah, I can see most of us are saying we extend. Yeah. So let's just extend for maybe like 10 or 15 minutes so that at least we can check these we can check this step. So this is how we do the renaming of this is how we do the renaming of the columns. But now with our data here, with our data set here, I think we are kind of sorted. So I think I can just maybe comment out this because we don't want to change anything. So let's stick to the names that we have for each column. There is also something else that you might want to do in your data set, and this is now choosing the drop in some columns. Let's say maybe you want to drop columns. Let's see these. This hash dropping relevant columns. Let me just copy something here. Oops, what is happening? This is column. Because you understand that during the analysis, like let's say you are just doing a simple prediction with this data set. Most of the when maybe you are doing when you are doing a prediction on player ratings, that is you notice that you are not going to use much of the data here. And now instead of maybe having also loading this data, it will always take time. And the only way you can you can solve that is by dropping the irrelevant, maybe try to reduce the data set. And this is where now we are talking of subs. You have a subset. You can have a subset of the data set uh, that you can use during the analysis. Like in this case, maybe we can try and let's maybe we just need a maximum. Let's have a maximum of 10 columns. Let's see these, like we have the Sophia ID, we have the what we can have the value for player, we have the age, we have the age of the player, and also have the height. So meaning that we can have a subset of these data. It's quite simple how we do that. And if you were to do the f dot, I think is the uh, we have df dot columns, and these are the columns that we have. These are the columns that we have. We have the player, we have the Sofifa underscore ID, the player URL, the short name. So let's say maybe you want to have a subset of maybe let's say these first five. Let's maybe have the first five. Uh, yeah, let's have just the first five uh, columns. Let's say maybe you want these just the first five columns. So how do we do this now? We can just have we can maybe have, let's say let's have a variable name here, and talk of what, let's have I think you can just call it subset sub uh, subset dataset. There is a number of ways you can by the way you can drop the irrelevant columns. You can either use the drop. You can use the df.drop. I think this one is the most commonly used, function to drop the irrelevant columns. Uh, but again, there is another simpler method. I think I can just show you what we have. Let me show you this. I think there is something we have here. Let me see this. There is a simpler way to handle that, like just having the having just a variable name, that is maybe the columns to keep. In this case, I was just using the columns to keep, and then naming all the columns that you want. So we can also apply this. Let me show you that. We can also apply that in what we have here. So we can just have that is a square bracket, and then we can just copy these. I think you can just copy what you want. Let's say maybe you want the first five columns here. So we can just copy these in these. So, and now when we try to print out this data set, let me just try to have these printed. Print the subset data set. So if I try to run these, Oops. Uh, just a minute. This is supposed to be df. Oops, am I missing something here? Yeah, I'm missing something to do with. There is something I'm missing here. Let me check that. Just a minute. Let me have df. Let's just call this df. df dot head. Because I think something is missing here. Let's check what is missing. We have df id Sophia short name. I think we have a problem. Let me see this. What could be this error? There is are we really missing something here? Okay, first let me just check if I'm able to access this data set. df.head. Yes, I'm able to access that. So if we can have df now, let me see this. Am I missing something? Let me just check this. In fact, I've just realized we are doing. There is a mistake we are doing here. Let me just uncomment these. Yeah, I think this now should work for us. Yes, I think this one is now working for us. We should use two square bracket. That is the first one for the list of columns that we want, and the other one is for the DF for our data set. So you can see that we have managed to have the first. That is the first five. That is the first five. That is the first five rows columns of data. So instead of now dropping the rest, I think this is the simplest way you can choose the columns that you want, because you're just going to have the df is equals to df is equals to your data frame, and then you just pass the number of the columns that you want to use. I don't know if we have any question. Do we have any question up to that point? I think that is it with dropping of irrelevant columns. Any question? Thumbs up if we are together. Yeah, I think that is it. So tomorrow we are going to continue with this process, so that at least now we can see how you can do the feature engineering. Uh, we check how you can replace null values, And then we do what? Then you are going now to check the third step, that is on features understanding. In the feature understanding, we are going to do some plotting, because again we are going to do some univariate analysis, that is analyzing each this is now analyzing doing the analysis of each column based on what you are told to, or maybe based on what you are asked to do, that is in any processing any data analysis task. So I think you guys, let's meet tomorrow so that we can continue now from here. Are we good? I think we are good up to that point. So can we meet tomorrow at 7? Yeah, you guys have a good